This tutorial covers what an ionic bond is, why ionic bonds have high melting points and boiling points, and also explaining when ionic compounds can conduct electricity and why. So first off, let's have some questions so you start thinking about some of the key points. First question we're going to look at is explaining what an ionic bond is. Sodium chloride has a boiling point of 1465. Do you think this is a high or low boiling point? Pause the video, think about your answer to the question, and then we will go through it question by question. This, I would say, is a high boiling point. How much energy, as in how much thermal energy, would it take to take solid sodium chloride and convert it to a liquid, and then obviously to convert it to a gas? This is obviously going to be a lot of energy. What type of ions do the green circles represent in sodium chloride? If it's a negative ion, it must be a non-metal ion, so it must be a chloride ion. What type of ions do the pluses represent? As they're positive ions, they must be metal ions. So they're going to be sodium ions. Is there a strong or weak force of attraction, do you think, between the oppositely charged ions? I would say you would go for strong, because it's obviously got a very high boiling point. What sort of forces do you think are going to be between the oppositely charged ions? Again, attractive, because it's going to hold them all together. If you think about an atom, we have a positive nucleus because of the protons in it, and these hold the electrons in electron shells. So oppositely charged particles will attract each other. This leads us to our definition of an ionic bond. Strong electrostatic forces of attraction between oppositely charged ions. How many ions or ionic bonds do you think are present in an ionic compound? The answer is lots. There are lots, because there are billions upon billions of ions. This is showing a very, very tiny amount of it. Most things can be split into two different types of structure. We have giant structures, which consist of billions of atoms or billions of ions. As we're talking about ionic compounds, it's a structure that consists of billions of ions. There are things also known as simple structures, which contain, say, less than 100 atoms, as a sort of general rule for sort of questions you would see. So, ionic compounds have giant structures. They've got loads and loads and loads of particles, which make them up. Loads and loads of positive ions, loads and loads of negative ions. And why do ionic compounds have high melting points? So if we think about what we had as our previous bit of question, they have giant structures, so we've said that they've got a structure which consists of billions of ions. If they've got a giant structure, it means they have lots of ionic bonds. So we could say what an ionic bond is. So it's a strong electrostatic force. Electrostatic means charged particles which aren't moving. And forces of attraction, we want to talk about attraction because it's holding it all together. And what's it between? It's between oppositely charged ions. You could also phrase this bit here, oppositely charged ions, as between positive and negative ions. And as we've said, it has lots of strong forces. This means it's going to require a large amount of energy to break the bonds and thus allow the ions to move. When do ionic compounds conduct electricity, and also why? If we look at the three diagrams, we've got three possibilities or something to start us thinking about. One is a circuit with distilled water. One is a circuit with solid sodium chloride. And the third circuit is one with sodium chloride dissolved into water and thus making a solution. If we look at the diagram, we can see there is a light bulb lit for a sodium chloride solution. This means we've got a complete circuit and electricity can obviously flow through the circuit. For electrical current to flow, what we need is mobile charged particles. What do you think the mobile charged particles are, or is, in one of the diagrams? The only circuit which has the light bulb lit up being this one. Now, in wires, there are things called delocalized electrons, which can actually move through the wires. But once it gets to this point, there are no electrons which are free to move, or delocalized electrons in the solution. So if we look at the diagram, you might be able to see there are some ions there. So we could look at a different version of a diagram. Here is a diagram of the circuit, and we can see a battery, so two cells together in this particular case, and we can see a little E- labelled on the wire. This is representing the movement of electrons through the wires. This bit here is a solution of sodium chloride, and we can see there are positive and negative ions in solution. So we've got charged particles there which could move. So in solution, the ions are free to move. If we think about it when it was a solid, if we go back one stage, the diagram of a solid had all the ions fixed in position and unable to move. So this is a key argument you'll be expected to recall. When solid, the ions are in fixed positions and do not move. When dissolved in water, the ions are free to move. Here's a diagram showing the dissolving of sodium chloride. We have a picture here showing the positive and negative ions in sodium chloride. And what happens is little water molecules can surround them so the ions can actually move and act as charge carriers. What other state, in addition to sodium chloride being dissolved in water, might ionic compounds conduct electricity? Can you think what might cause the ions to be able to move? We look at a little diagram on the right. As a solid, it doesn't conduct electricity. But in this picture here, it does. This is where it's been heated up, so it's molten, so as in liquid form, and the ions can move. Here is another picture showing the ions being able to move in water, and here is a solution of water which cannot conduct electricity because it has no charged particles present. So the argument completed looks like the following. When solid, the ions are in fixed positions and do not move. When molten or dissolved in water, the ions are free to move. A recap of the key information covered. What are ionic bonds? Here is a set of pictures which will hopefully guide you to the correct answer. Pause the video, then push play. The first picture is representing strength, or someone being strong. Here is charge moving, so electro to do electricity, and static, so electrostatic. Push and pull are examples of forces. Magnets attract things. Obviously they could repel things, so hopefully you've got an idea that it's attraction. And what's it between? It's between oppositely charged ions. The next one. Why do ionic compounds have high melting points? Ionic compounds have, maybe pause the video before you watch it rather, and find out the solutions. So Jack and a Beanstalk, so have giant structures, so they have a very big number, so lots of, again our picture representing strength, so of strong electricity and static electricity, so electrostatic forces of attraction between opposites or antonyms, so oppositely, and here's a cat being charged up, so an ion, so oppositely charged ions which require a lot of energy to overcome to allow the ions to move. The last one, why do ionic compounds conduct electricity? When solid, the ions are in fixing, so fixed positions, so do not move. When If cats could be described as a state of liquid, this might be representing it. So liquid or molten, or this is showing dissolved in water. The, again, pictures for ions are, and again, in your free time, what you do, you might go to the beach, so free to move. So the last bit is, I hope that's been very helpful. What are ionic bonds? Strong electrostatic force of attraction between oppositely charged ions. Why do ionic compounds have high melting points? And when do ionic compounds conduct electricity? So we'll finish it there. I hope that was helpful. If you've got anything you feel would be better clarified or could explain more, please let me know. Thank you.